Hello everybody. Here's your lesson for chapter 8, the first lesson on graphing rational functions. So a rational function, this is the parent function of a rational function. So the one I have on the screen here is f of x equals 1 over x. That's about the simplest kind of function that you could have. Every time we do a parent function, we're always going to create a table to do that. So here's my XY table. And then we obviously pick points. So I'm going to start with our good old standard 0. And then if I substitute a 0 in for x, I get 1 over 0. Well, 1 over 0 is undefined. So I'm just going to put a circle with a line through it to signify undefined. And let's just do a couple more. Let's do a 1. 1 over 1 is 1, and then a 2. If x is 2, 1 over 2 is 1/2. And if I keep going with this pattern, we get 3, 1 over 3, 4, 1 over 4, etc. So let's do a couple negatives. Negative 1, substituting in negative 1 for x, you get 1 over negative 1, which is negative 1, and negative 2, which would be negative 1/2. So now if I'm going to graph these points, the 0 is undefined, so there is no point on the y-axis. So anytime you have a 0, let me try to use like a little laser pointer here. Anytime, oh look, my lightsaber comes up here. Anytime along this y-axis, these are the ordered pairs when x equals 0. So this y-axis has no points. That's actually going to be our asymptote. We'll get there in a second. So as I graph these, 1, 1, I'm going to do my best here with my stylus, is right here. And then 2/2 is a little bit lower. 3 1/3 is a little bit lower. And as you can see, I'm never going to go past the actual x-axis. So if I graph the negatives, we get -1 right here, and -1, -1/2 right there. And you could keep going, -1/3, -1/4. I wonder what happens when x equals half. So let's look at this. Excuse me. So if I put x equals 1/2, you get y, or f of x, equals 1 divided by 1/2. You can't divide fractions. You can only multiply by the reciprocal. So 1 times 2 over 1 is actually equal to 2. So if my x is 1/2, my y value is going to be 2. So then it kind of goes up like this. And if you can see this pattern, what's happening here is this is what a rational expression is going to look like. It's this little branch like this, and if I did more points over here, the negative area would be the same thing. It would look like this. This is actually called a hyperbola. Now, you do have an asymptote here, so you actually have two of them. One of them is this asymptote here, which is the y-axis, because you cannot have any zeros in the bottom of your fraction. So anytime you have a fraction, figuring out what makes this 0 gives you your vertical asymptote. And this actually has a horizontal asymptote too. There's nothing added out back, but I'm just going to put a +0 there, and that gives you your horizontal asymptote, which is y equals 0. So your domain is going to be all real numbers, left to right, except x cannot be 0. And my range goes up and down. This graph goes all the way up forever and all the way down forever, except it has this little gap here at this asymptote. So the range is also all real numbers, with the exception of the x-axis, which is y cannot be 0. So that's our parent function of just a simple rational function. A rational, the word rational means fractional. So a fractional function has a fraction y. Okay, here's the next one. Now I did jump to example 1D because I'm trying to give you only the bare bones of what you need. So I'll first of all start with the asymptote. So this has a denominator also, but the question is, how do you get the vertical asymptote? So for the vertical asymptote, and these will have both usually vertical and horizontal, the vertical asymptote is when the denominator equals 0. So when does that denominator equal 0? If you're unsure, take the denominator and figure out what value makes a 0. So you might have to do some solving. I could have done this one in my head, but you get x equals -1. So that is the vertical asymptote, x equals -1. What about the horizontal asymptote? Well, the horizontal asymptote, I'll put that in red, is always this number out back. So that's kind of like the h and the k thing that we've talked about all year long, but in this case, this number that's added to the end, that's going to be our horizontal asymptote. And if you did points here, you would kind of see why this happens like this. So now if I was going to graph this, I'd immediately go with a vertical asymptote. I'll put that in blue of x equals -1. So that's going to be like right here. And my horizontal asymptote, I'll put that in red, is y equals 3. 1, 2, 3, that kind of goes up here. And now I'm going to have my hyperbola graph, which are two branches that curve around these asymptotes, one of them in one of the quadrants and one of them in the other quadrant. So how do I figure that out? You could absolutely make a table of values, and let's just put a few thoughts together here as we do this. So since x can't be -1, well, let's pick a number to the left of -1, which would be -2. So if I pick -2, I'm going to put my work over here. I get y, or f of x, equals 1 divided by -2 plus 1 plus 3. Watch your order of operations here. So -2 plus 1, the denominator is -1. So this becomes -1 plus 3, which would be actually 2. So -2, 2 is a point. So if I go -2, +2, I get a point right there. That kind of tells me where my branch is. I'm going to actually graph this guy in green. So since my point is there, it looks like my branch will go there. Now the other question is my other branch going to be in this quadrant or in this quadrant? As you do enough of these, you'll kind of see how they go. But let's just pick a point that's to the right of -1. So if I pick a point to the right of -1, I'm going to pick like 0. So here's my work for 0. Y equals 1 divided by 0 plus 1 plus 3. So this is 1 plus 3, which equals 4. So then 0, 4 is a point. So 0, 1, 2, 3, 4 is up here somewhere, and then you can see, okay, my branches go like this. You could absolutely do more points if you were unsure, but these guys are always going to be two different branches that go on different parts of these like 4 quadrants here. I'm calling these quadrants as the asymptote split them into 2 branches. Well, what about the domain? The domain is always going to be all real numbers except x can't be, in this case, the asymptote is -1. And for the range, you get all real numbers except the horizontal asymptote, y equals 3. So there you go. There's example 1D. All right, so these real quickly, if you want to pause the video and try these on your own, you absolutely can. Identify the asymptotes, domain, and range of each function. So in this case, if you had a chance to try it, the vertical asymptote is what makes the denominator 0. So 2 minus 2 would give you 0. So if you think about it, 3 over 2 minus 2 produces 3 over 0. You can never have a 0 in the denominator, and feel free to check that in your calculator. Hit 3 divided by 0 on your calculator, you're going to get something that says error domain. So in that case, I do know that -2 is my asymptote. So +2 is my asymptote. So here we go, 1, 2. So here is my vertical asymptote, x equals 2. Horizontal asymptote, there's nothing added out back, so you're going to have a y equals 0. And now you can see those 2 branches on both sides. And then I'm going to quicken this video up pretty much, and my domain and range are basically going to be all real numbers for both of them, except for the domain, x can't be -2, and for my range, y can't be 0. And then this guy over here, what do you think that vertical asymptote is? You got it. it's x equals negative 2. And what do you think that horizontal asymptote is? Y equals 1. Now these functions do get more complicated. Oh, this is kind of a bad one. Sorry, with this thick stylus here, kind of hard to draw straight lines. I'll put the actual asymptotes in here. X equals negative 2, comma, and horizontal is y equals 1. And then once again, domain and range is the same thing. Domain is all real numbers except x can't be negative 2, and range is all real numbers except range, remember, is y. Y can't be negative 1 because that's the gap. Feel free to give this one a try, and then I'll start going through it silently so you can see my work. But if you want to pause and come back to it and see how you do, that's perfectly fine. Okay, hopefully got through most of that, and now the only real question now is where do the branches fall? We could try, obviously, some points. So if negative 1 is my asymptote, if I substitute that in, I get undefined because you can't do 2 over 0. So then let's pick a number a little bit bigger than 0. A little bit bigger than negative 1 is 0. So if I substitute it in, it's f of x or y equals 2 over 0 plus 1 is 1 plus 3, and that gives me 5. So 0, 5, where does that happen to go? 1, 2, 3, 4, 5 up here. So I'm actually going to change color so you can see what's happening here to green. And then that branch will be up here. Now, how curvy are these branches? They merge right into those asymptotes. Remember, the curves get closer and closer to the asymptotes without touching them. All you have to do is really have one point, and I will know that you've checked to verify where those parts of the curves go along the asymptotes, and you should be good. So let's just check another one. The other side of the asymptote, x equals negative 1. Let's check a negative 2. So then I go y equals 2 divided by negative 2 plus 1 plus 3. And this becomes negative 2. 2 over negative 1 is negative 2 plus 3. You get a 1. So this is going to be 1. So negative 2, positive 1 is right there. Let's change again to green. This curve that fits this is actually only these two branches right here. And asymptotes are very important. In fact, with the current coronavirus strain they're looking at, there are asymptotes. When you get into studying logistic curves later in your math career, you'll definitely talk about the asymptotes and what they mean and effect of like a virus. And then example 3b. Now this one does have a negative 4, so you got to be careful here. So once again, asymptotes is x equals 2. And y equals negative 1. Nothing changes there. So let me graph these. So in this case, I'll graph the asymptotes in green. X equals 2 is right here. Y equals negative 1 is right here. Now where do my branches go? Let's check it out. Make a table. So I'm substituting in something around 2 because that's my vertical asymptote. So the horizontal asymptote is the y value. Remember, x is your input. So that's why you always want to input points or ordered pairs around 2. So what's bigger than 2? 3. So let's check a 3. So you get y equals negative 4 over 3 minus 2 minus 1. That equals negative 4 over 1 minus 1. Negative 4 minus 1 is negative 5. So 3, 1, 2, 3, negative 1, 2, 3, 4, 5. So now my branch, if you can see it, is over here. And what about something a little smaller than 2? How about 1? Check that out. Y equals, I'll do a little work in my head here. We got -4 divided by 1 minus 2 is -1, minus 1. A negative over negative is a positive, so I get 4 minus 1, which equals 3. 3. So 1, 1, 2, 3 is up here, so this graph is going to go like this. Okay, so remember the asymptotes, I like to put them in as dotted, and the branches, I like to put them in as solid. Your homework assignment for this is going to be these problems here from your book, and then I've also I have this copy here for 29 as you do these last two, number 29 and 38. This digital copy will be available for you to print off, or you can put in your notebook, but it's about working on construction, about the pounds of a beam that can carry distance. So the longer the beam, the more pounds it can carry, and this is the equation. So as you do this, remember D is in the fraction, so that's going to be like your x, and your p is going to be like your y as you go through this. I've created a graph for you to create this and make several points along this one, and then don't forget to answer the question as you go through this problem. Thanks for listening. There is your assignment and your lesson for 8-2.